Welcome to WPA Mechanical Training. Today we are going to talk about Newton's laws of motion. These laws are the foundation of understanding how forces work and how they respond to each other. Sir Isaac Newton was one of the greatest influential scientists of all time. He is credited with discovering gravity and is known as the father of calculus. He formulated the three laws of motion. The first law of motion states that an object in motion tends to stay in motion, and an object at rest tends to stay at rest, unless acted upon by a larger force. Let's break that down a little. We can see that this ball isn't going to move, while the rolling ball is going to continue to roll until something stops it, which may be friction. Friction will be talked about in a later video. Newton's second law is actually a math formula. It says that force is equal to mass times acceleration. A force is a push or a pull. When a force is applied to an object, it can move or accelerate. It can also stop an object or change the direction an object is moving. Force can be created by a lot of things. We have the ability to apply forces to objects, but so do wind, motors, and engines. Gravity and friction are two major forces that affect the motion of objects. If less force is applied, there is less acceleration, whereas if more force is applied, there is more acceleration. An object's mass also plays a role in a force's acceleration. If we kick this soccer ball hard, it will accelerate greatly. A bowling ball has a lot more mass. If I kick it with the same force, ouch, it will not accelerate as much. Lastly, we have Newton's third law of motion. This law states that every action has an equal and opposite reaction. So when we apply a force to a ball, the ball pushes back with an equal and opposite force. Think of a desk. I'm exerting a force down on my desk with my computer and arms, and the desk is reacting by having an upward force that is equal and opposite, and so nothing is moving. In summary, Newton's first law states that an object will remain either at rest or in constant motion until acted upon by a larger force. Newton's second law describes the proportional relationship between force and mass and acceleration through the equation of force equals mass times acceleration. Newton's third law states, for every action, there is an equal and opposite reaction.